So welcome. Thank you so much for joining us this morning, the first workshop of your time here at NSTA. I'm excited to be presenting today to you. My name is David Farina, and I am a 15-year teacher of Earth and Space Science. I teach in a planetarium, and I've been teaching in the planetarium since I started at age 22. And I teach all the way from the youngest elementary students, kindergarteners. I've even had some pre-K kids in there, all the way up through the high school, which is where my main requirement is, where I'm housed, is my office, or if you will, my classroom is in the high school. So majority of my schedule is high school schedule, but I do see the full spectrum. I also teach at a local community college. So, depending on where you're coming from, I have some background and understanding of your areas of interest. So when I first got started in my teaching, although I have a background as a Earth and Space Science educator, and that's my official degree, I got myself into a situation where I was teaching multiple astronomy classes, and I didn't really have confidence that I could really do it without some help. And although I had like 4 astronomy classes in college, it was kind of scary. I mean, there's nobody to talk to. There's nobody who teaches astronomy at the high school level, it seems. So I was very kind of taken aback by this huge task I had, which was to kind of teach myself astronomy. And in my searching for answers, I came across a software called Starry Night. And Starry Night is what we're going to be discussing about half of our discussion today. And Starry Night is a simulation software that can be helpful for students to understand things that are very large, of course. The cosmos is an enormous place. And also, just not the right time of day, right? We teach astronomy in school, and it's daytime, and nighttime is when astronomy is happening. So that's challenging. I can't even use the real environment during the school day. I have to get them to come in. So we're going to be talking about that about half the time today. The other half of our discussion today is going to be on the layered Earth. Now, the layered Earth is the other half of simulation curriculum, the developers of these software, which is actually multiple different things. There's geology, there's meteorology, there's physical geography. So there's quite a bit to talk about. I'm by no means going to be able to talk about absolutely everything today. So I'm going to give you a basic overview of how it works and what it provides you as a teacher and as students, what it provides them to be successful in your classrooms. In having this software at my disposal, I found that I was more comfortable in teaching these concepts. I also teach the geology and meteorology classes, so I've started to use the layered Earth more recently as well. So you can also, if you go to the booth, get a chance to get some hands-on opportunity with the software that I'm going to be showing you today. They'll provide you with a 10-day free license to explore and check things out for yourself, which I highly recommend. It's one thing for me to present it to you up front here. It's a completely different experience for you to be able to browse it yourself. And so definitely make sure you get up there to do that. You can also, if you go up there, enter to win a 1-year classroom license. So, being that you're here and you have a chance to get that 1-year license, that's pretty cool. Somebody's going to win it, right? Somebody's going to win it. Also, special convention pricing. So they, provide you significant discounts because it's at NSTA that are only available here at NSTA. And you can get a quote and you can carry that back to your school. I realize you can't make decisions, right? You have to go and get asked for permission, but you'll have the quote in hand and it'll be honored. When you are accessing, or students are accessing any of these products, they're actually not having to download anything. And this, as many of us are aware, can become very helpful. My district, I've been using Starry Night for many, many years. 15 years ago, it was on my laptop cart, and it was in one room, and if students wanted to have access, they had to come to me. And it wasn't even my laptop cart, it was my neighbor's laptop cart, and so if he was using it, I couldn't use it, and it was a mess. Now, fortunately, we're one-to-one now with iPads. But if students forget their iPad or they forgot to charge it, right, or whatever, they can access it on their phone, they can access it on their home computer, they can access it from any device that has a modern web browser. And that never became apparent to me how important it was until COVID, right? I had students at home, I had students in my classroom, I was teaching live, and yet I could have them access it with pretty high confidence they wouldn't have any issues. So they'll basically get a login code, which will be at the login.simcur.com. And once they're on that login, this is the first screen that they will see. Now, if you have only one of these products, let's say you get the Layered Earth Geology, this is the only one that will say Launch App, and the rest of them would just say no license. Okay? If you purchase multiple, then you can actually have them all, once again, it's a single sign-in. All right? So you're not going to have to worry about a code for this kid or a code for that kid. It's just a code for everybody. And you'll get a set number of seats that you can have logged in at a particular time, just like your Netflix account, right? Where you can only have a certain number of devices attached to that account at a particular moment. So you'll get your launch app screen here, and from there, it's just going to load. Now, once you get into this is the Starry Night software, and it looks pretty much the same, no matter if you're going to have the elementary, middle school, high school, or even college. All right? There's a college textbook edition that looks way different, but this one is the main way that you would see the user interface for this. On the left-hand side is the Sky Guide, and that is basically the launching point for all of the different pre-made lessons, okay? And so you can see we're categorized into, a bunch of different categories here, and then you've got this area. Now, this area is not static, okay? It is interactive. Once again, this is the Sky Guide. This is where students will click to go into a pre-made lesson. But this part is an interactive, so I'm actively able to move this around. I'm actively able to, zoom in on things, and you'll notice that as you zoom in, that there's more information. As you zoom out, that there's less information to keep this clean and easy to understand. And you can click on an object, and you can determine, more about it here. So if we wanted to learn more, we can show info, and it'll give you a bunch of information here. I know, sorry, it's a little bit small to see here, but there's a lot of data and background information on that particular star that I clicked on. I can even zoom in on it. I can fly there and actually go to the object itself, and I'll be doing a few of those in just a moment. This user interface at the top is your time controls. So we've got date and time, which allows you to go really far into the future. So if you want to find out what things are going to look like in 20,000 years, you can do that. It's actually accurately drawn or simulated in the software. If you want to go back in time and see what it was like for the ancient Egyptians when they looked up at the night sky, which was different, right? Not dramatically different, but because of Earth's precession, right? As it kind of spins and like it wobbles like a top, they would have had a different North Star. And this simulation actually accurately makes that available and easy to see. So to try to explain these things like precession to a student is very difficult. But when they can just interact with it, with the simulation, it makes a ton of sense. You also have your location. So right now it's set to San Francisco, California as a default. But you can come in there and you can make it your school. Okay? You can make it ancient Egypt. You can go anywhere on Earth with this, and you can find out where you want to be. So if I want to come in here and I want to go to a map or something, and I want to find out, okay, I want to be at my home, you can simply search for it up here. So I would say Lancaster, PA, oops, sorry. And it will actually find Lancaster, PA, and then I can click on the map, and that will be my location now in Starry Night. And you'll see it actually says Lancaster, PA, if you can see that, up top here. So now that I've done that, everything that the software is drawing is as if I were in Lancaster, Pennsylvania. So, you know, for example, the height of the North Star Polaris is equal to your latitude, right? So if you were to take you're able to measure with like a protractor, 40 degrees north latitude is what Lancaster, Pennsylvania is for the North Star above the sky. If I go to the equator, that latitude changes, right? And so now, instead of it being 40 degrees above the horizon, the North Star is on the horizon because I'm at the equator, 0, because it's equal to your latitude. If I go to the North Pole, now the North Star is actually at my zenith. It's directly over my head. And that changes everything as time moves forward, right? As the sky turns in day and night, diurnal motion. So that can be simulated as well. So let's say we want to go fast. Let's say we want to go really fast. We want to change by years, okay? And we hit play, okay? Now we have the simulation running that as the computer is refreshing, it's saying days are going to be counted, and the days are up here flying. We're already in the year 2113. And so the ability for you to show things in an accelerated way is extremely helpful, right? And you can do it this way, or let me just hit home quick, or you can do it in a way that is more manual, and you can click forward one day at a time. So for example, I use this one day at a time for students to see things like, okay, if you watch here, we've got planet Mercury up in the top right-hand corner, and just keep your eye on that, right? Planet means the wanderers. They move. The stars don't. So compared to the background stars, if you look, Mercury's on the move. Try to explain that to a 13-year-old, right? And it's difficult, but they can see it now. They can see day by day that the planet Mercury is on the move. And so these are really, really helpful. This is all stuff you can do without the aid of this. But then there's all of this. There's a lot of stuff here that's all ready to go. And there are activities that go along with it already with answer sheets. There's little quizzes that go along with that if you'd like to use those. There are hands-on activities that are linked to all of these as well. And all of this is in a very comprehensive standardized test-aligned teacher's manual. So there's ability to connect to it to learning management software. So if you're using Google Classroom, in fact, if you look at the bottom corner here, you can assign things through Google Classroom. And it's able to be integrated to other LMSs as well. So I use Schoology, for example, and I have them working kind of in a weird way. I have them working through Google Docs, but I post it on Schoology, and it works out really well. And then they can submit their assignments. So it'll just launch you right to Google Classroom. Now within here, let's see, the solar system. I've got the ability to click on through here, round we go, for example, and it automatically updates the way it looks. So once again, this is completely interactive, but I tell students, you have to read through this. There's no way to understand the activity that they're doing without reading through this. And it will not only give them the information they need to help them to understand this, it asks questions that basically they have to do the simulation in order to answer. Okay, it's not like a facts thing. It's asking you, as you're watching, how far away is the planet Venus at its greatest distance? So let me just pause the animation quick. So I pause the animation. I can come in here. I've got different tools. I got a measurement tool, and I can click on Venus, and I can drag it to the sun, and it tells me that at this particular moment in time, Venus is 0.719 astronomical units from the sun. 1 astronomical unit is 1 Earth to sun distance. If I now hit play, as time moves forward, Venus is going to go around its orbit. It doesn't maintain that exact distance. It changes over time, and they can see this live, and it's accurate. This is not just a made-up number. These are actually the distances it would be to our best of our current data. So very powerful, accurate measurements. It's really hard to do in astronomy without this software. I've found that out, over the years. This is really helpful. So the inquiry side of things, as we're trying to find ways for students to have to think outside the box, like I said in my video, it's lab first. Deep end. I don't even talk about it at first. I just say, hey, here's this concept. Play with the simulation. And I do follow up, and I teach, maybe a hands-on activity or something, or at some point I will go over it, right, as a review in some sort of a presentation format where I'm up front. But the lab-first approach I've found, I didn't start doing that when I was first teaching. I'd present. I'd try to tell them everything I knew and wring my brain out to them and say, here's everything I know. And it just didn't work. But what I'm finding is as they do it, they come up with questions as they're doing it. I'm just browsing around the room, drinking my coffee. Questions are asked or not. That's up to them. They can work by themselves or they can work with others. And some of the questions I get are just way, way more than I ever thought would be asked, right? And so it's really nice to be able to have them doing this first, because what I'll do then is in my presentation afterward, in my review, I'll be able to refer back to this simulation and say, remember when you were doing this on Starry Night? Oh yeah, okay, well that's what we were trying to show you. And it really makes those connections for them, and it gives them the ability to play with the simulation, which I really do like. Okay, so this is Earth, and all those green dots represent satellites. And they're actual satellites. These are mapped, and we know their orbits, and the software knows where those satellites are at a given time as a result. And so we really are going to have to determine what do you do with these when you decommission them. We're already starting to see what's happening. There's a bunch of movies out there, right? So these are some interesting concepts that students, I think, are really going to have to be, the ones to start to understand. And, I don't know if you've been paying attention to the, SpaceX and Amazon and things are trying to launch satellites on the order of 50,000 for one array. So the space environment is going to become more important, I think, over the next few decades. And, the understanding of these ideas, I think, are very important. So we can talk about different orbits and all sorts of things with that. Just trying to watch my time as we move into about 9 o'clock. And around 9 o'clock here, I'm going to switch over to the earth science concepts. I want to show you one more thing within this, which is galaxies and the universe. So the ability for us to simulate things does not just come from Earth's perspective. Here we are orbiting the sun. The sun is in the middle there, as you can see, labeled. And these are properly three-dimensionally mapped stars. So Proxima Centauri, our closest star, is properly located on this three-dimensional model in real, in three-dimensional virtual space. And I can stop the simulation at any time. I can click on a star, and I can find out its name. If I want to learn more, I right-click, I show the info, and we can learn everything we know about that star. And if they can't find it here, they can click More Info, and then there's even more to look at. So, these are not just dots on a screen. They are actual data points with more if you click into it. As we zoom out, here's our home galaxy, the Milky Way. Once again, it is not just a picture. It's a model. We've got some of our local group. If we want to zoom in, we can simply zoom in here, bottom right-hand corner, plus sign. And as we zoom in, we're going to go from our view of the Milky Way as a three-dimensional galaxy. And the little stars you're going to start to see here in your picture are still data points. It's not a just dot on your screen. So the ability for them to zoom in or zoom out for that matter. Let's zoom out. We can keep zooming out. So this does not have the entirety of the universe. Sorry, it's infinite. But it does provide you the ability to really start to get a handle on the scale of space. There are some in the origin and evolution of the universe. How did it all begin? There's the cosmic microwave background radiation. Yes, this is important. So the sky is not just the visual spectrum. There's the ability to have all sky maps of different parts of the electromagnetic spectrum as well. So if you want to show students what it looks like in the infrared or the radio or the UV, there are databases that are provided by these large observatories, space-based or land-based, that are accurately displayed here as well. So what I like to do is, for example, I like to show them, let's say, the Orion Nebula, right? A star-forming region. It's beautiful in the visual spectrum. But if you click over to the infrared, it tells you even more, right? We can see through the dust and gas now, and we see different details. And we can literally toggle these on and off to reveal different structures within that nebula. And so students really understand the importance then of why the electromagnetic spectrum allows us to see these different components and how each of those different telescope types and each of those different types of light are important for astronomy. And I liken it to like an X-ray on your body, right? We have X-rays, we have MRIs, we have all these different things, and they get it. It's very visual. So let me just keep going here real quick. Hubble Deep Field, and more. So lots to see here, and it's still not done. If you are a real go-getter and you really want to make lessons for your students that are custom, I have a lesson. I want to teach this concept. You can actually load your own files. You can make your own favorite files if you're interested. You move things around on this screen, and you can save that. Save to Google Drive, save to local drive, and then you can have students open those files up, and it'll load whatever it is you wanted them to see. So you can design your own lessons in that way, which is awesome. I do quite a bit of that with stellar evolution. So there is the ability to customize things as well. All right, I don't want to miss the opportunity here to switch over to the layered Earth stuff and have some time at the end. The layered Earth is going to go a little bit more quickly. I did see a lot of people say geology, and a lot of people say physical geography. So I'm going to choose the geology one, but please, once again, if you have questions or want to see more, you can go to the booth. booth 773, and that will allow you to get the 10-day license to be able to play around with these on your own. But I'm going to jump into the layered earth geology here. You'll notice that when we get into this, it's very interesting because it's fairly similar, right? On the left-hand side, we've got our Earth Guide. Sky Guide before. Now it's Earth Guide. And there are student lessons here. There are teachable moments. There's the workbook, product tour, online education portal, and then there's an Earth, right? And on the Earth, once again, just like in the Starry Night software, this is not just a static thing. Now, many of us are familiar with things like Google Earth, right? Very similar here, except for it's made for educators, made for students, and has lessons attached to them. But, you know, this is completely interactive. We can zoom in on this stuff and see it in greater detail. We can, let me go to the student lessons quick, just in the name of time. I saw someone had said about plate tectonics. So let's take a look at some plate tectonics stuff. And let's take a quick look at paleomagnetism. This is one of my favorites. Anybody teach paleomagnetism? Okay. So if you're not familiar with paleomagnetism, right, the Earth's got plates, and we've got the mid-Atlantic ridge here, and it's spreading. And as that spreads, the magnetic poles of Earth are switching over time. And I've done a number of activities where, you know, students are pulling paper out between two desks, and these are all still things you can do, right? And as they change, they color different markers, and they try to figure out, you know, oh, the Earth's flipping its magnetic poles. Okay, well, how does that relate to the Earth? It goes through, once again, you have to read. You have to read to be able to get the understanding of what you're to do over here on the other side. By the way, if you and this goes for Starry Night too, if you mess this up, this over here on the left-hand side is just a web browser. Hit refresh, and it fixes that. So I tell students, you can't break it. There's nothing you can do that breaks this. Just refresh it, and it'll go back to the beginning, and you can try again. Because a lot of students are like, I don't want to break it. You know, they don't want to mess things up. So you can look at different times, and it shows you like where the Earth's magnetic pole was at different times. Here's 1904. Here's 1948. Here's 1962. And it'll walk you through, you know, the path of the migration of Earth's North Pole, in this case, over time. Interesting, right? Here's a map. Okay, and we've got a scale here of the field strength of various places on Earth. So once again, very visual, gives students an understanding, oh, wow, this is not just a uniform thing. My compass is not necessarily going to work the same everywhere, right? So this is kind of a helpful thing. There are, at times, some simulations within the simulation. Okay, we can play through and describe things in a different format here that are maybe more applicable. And here we have age in millions of years ago. So students can start to understand, wait a second, oh, as you get closer to the mid-Atlantic ridge, it's younger, and as you go closer towards the coasts of North America and Africa, it's older. Interesting, right? And inquiry-based. Keep in mind, I haven't talked to them yet about this. They have no clue what they're in for. They're in the deep end trying to tread water. They read through this. They ask questions of me if they'd like, and if they have, I'd more like them to talk to their partner first, too, before they talk to me. They come up with some really interesting ideas as they're walking through this and as they're answering questions from the activities. And so the ability for students to see the simulation is beyond important. So that's the plate tectonics, just one lesson. There are many, you know, continental drift, seafloor spreading is what I just showed you, the theory of plate tectonics, okay? So, you know, you can show all sorts of things within this as well. I'm going to talk for about 5 more minutes and give us some time at the end. Let's go with one more lesson here. This is one of my favorites, volcanoes. So let's go with types of volcanoes. Similar to Starry Night, we've got on our right-hand side here the simulation that is completely interactive. Now I'm zoomed down in very close to a volcano, and it's 3D, and I can swing around it. I can look at it from different angles, and I can, try to see more details as I zoom in. I can zoom back out. You can pick any volcano on Earth, yeah. So let me see if I can get to that part, since that's a question that I want to be able to answer. Let me just go back home quick and show you this. So I'm just going to go to the layers. So you can just toggle things on and off. So I'm just going to go to volcanoes here, and then I'm going to toggle on, let's say hot spots or something, and it'll show you on Earth where all of the hot spots are, right? I can come in here and I can say I want to see the Ring of Fire, right? And I want an outline of the Ring of Fire on there to talk about where the Ring of Fire is and what it is. You can click on these just like in Starry Night, and you can learn more about them. Some of these volcanoes are in the ocean, like this one, but if they're on land, you can choose them, and you can view them up close and get more information on each of them. They're each a data point. Other questions, because I'm running low on time here. I've got 8 minutes, and I can try to show things. Is there something within this software or Starry Night that you'd like to know if it's here? Yeah.
So you mentioned that in Starry Night, the different grade bands have the same UI. What is the difference?
So the lessons are different based on the different groups. So if it's an elementary lesson, we're not going to ask them about Kepler's laws,
I guess I'm mostly wondering about the ones you were showing us were very text-heavy. Is that also true?
Simplified text also, for sure, and less on the UI as well. So the user interface as well. So it's going to be simplified to match that elementary level, for sure.
For that information that is given, is there a setting where that can be read to the student?
So it's a browser, right? And so as long as your browser supports it, it is possible. I've had some luck, and it's not like native to this software. I've even had some luck. I have some English learners, and I've highlighted it, and within Google Chrome, you can translate live. And so I've had some luck with even that. So yes. Any other questions? Sure.
What's the reading levels? Are they like if it's a 6th grade, is it a 6th grade level?
So the fact that there are different the different options here. If you were to go with the elementary level, that one I can't actually show you. That one is geared more on the upper side, I would say, of elementary. But if you get to like 4th, 5th, 6th grade, I'd almost recommend going to middle school. Right? And honestly, middle school, if they're upper middle school, you probably can get away with doing the high school version if you want more. Yeah, for sure. For sure. And there is overlap, so that kind of to point that out, this is a good question. So if you have like a few students who are going to struggle with a particular reading level, there's overlap in some of the lessons, not all, because there are certainly more lessons for high school and college. But basic things like phases of the moon, for example, are going to be seen at multiple levels. So if these students are not going to be able to handle this, but I have some kids that are really going to be bored, and I want them to be advanced, there's ways to do that. And these are separate licenses, but I think you could certainly talk to them at the booth and learn more about that. Other questions?
Do you know much about how often it updates?
How often it updates?
So like with the James Webb Telescope images coming in right now,
Yeah. So it's always being updated. I'm involved at some level on trying to do some of those updates, hopefully, with James Webb. I have, if you're interested, come to the booth. I can show you some of the things that we already have. And it's evolving. Of course, as those images just came out last week, but we're going to try to get things up and running soon. Yep. So I see a few people walking. That's OK. But I just want to just remind you one last time of the booth and the information here. So once again, there's the information. Booth 773. You get a 10-day complimentary 10-day license. Please do that. I can't express how much more there is to this that I can't even scratch the surface of in an hour. 1-year license, you can enter to win. And don't forget the special event pricing that we can provide only here at NSTA.
Does the teacher information come with the classroom license, or are they separate?
Does the teacher?
Like information?
I mean, so you're going to get like a packet, a PDF with everything. Right, right. And that's like the lessons and the teacher's guide and all that. That's included, yeah. Yep. Thanks, everybody. I'll be here for a few minutes. If you have any questions, feel free to come up.